Hello everyone, my name is David Varela from the Manufacturing Technology Center.
Hi, I'm Jose Maria Blanco from the MTC.
And today we are here to talk to you about the social disruption of Telexistence. Over the last few months, enabling remote working practices became one of the top priorities for businesses and organizations around the world. The need for keeping the operational engine of the business going accelerated the adoption of some already established and some others more innovative solutions to enable collaboration and communication across teams distributed around the world. This need was perhaps further motivated by the multiple challenges that many manufacturing businesses supported to provide frontline health workers with the equipment they needed to keep saving lives. However, before all that, at the MTC we were already working in remote working concepts, but on a totally different scale, an interplanetary scale, as we were developing the concepts for remote working on the surface of Mars.
So, why Mars? It can be the curiosity, it can be the resources, or even to have a new base in another planet to avoid extinction. There is multiple reasons to shift our attention to the deep space and Mars in particular. But it's not an easy task. 8-month long trip in a really small can expose it to radiation, can have a massive impact in the crew. And once we reach our destination, we find a hostile environment with no food, no water, and no air. And it creates a massive dependency on all the resources sent from the Earth. And remember, if you have any accident, you are completely helpless. So if you saw The Martian, the movie, you know that it's not a funny adventure. So maybe send the robots first. The usage of robots can take advantage of one technique called in situ resource utilization, where all the required resources are gathered in situ until a stable colony is set in place. Some companies like Space, they are developing the next generation of autonomous robots. The robots can start researching, gathering data, or building a self-sustainable base for humans. But the autonomous robots, even with the benefit of avoiding the 8 minutes to 1 day communication delay, the complexity of the task, a high dynamic and unknown environment, can put on risk a complete mission, resulting in a cost of some millions of euros. A semi-autonomous teleoperated activity can be defined as the safest and cost-efficient alternative. And don't forget about the possibility of robots racing against humans and taking control of the planet. The term telepresence has been in the global mind since the 80s. Remote holographic communication that allows sensing, interacting with another world, and having a natural and permanent influence on the environment. This is a technology that has been researched and tested during years to control our first generation of Martian and Moon rovers. So, until today, all these operations have been performed through what is called a human-robot interface. Normally, it's just a simple joystick with 4 haptic feedback technology, a lot of cameras and screens, and an operator performing really skilled and complex and unnatural interactions that require a high level of expertise with the tool. It seems pretty obvious to me that the next step should be how we can reduce this massive skill gap and how we can process all the information coming from the environment so the operator can perform quicker in a more natural and efficient way. We can start with stereoscopic cameras, adding perception of scale and depth. Also anthropomorphic arms and an anthropomorphic point of view is something that already fits in our XR technology. We can wear a head-mounted display connected with a robot, and we can start interacting with a remote environment. But probably we will start hitting and breaking things, so adding a dexterous manipulation and haptic feedback is an important step. On top of that, we can add an extra layer of visual feedback in the form of augmented reality. Things like path planning, obstacle avoidance, or proprioceptive data can be integrated to increase our environmental awareness and to support the human operator. The graphical interface plays a key role in the overall performance and success of our task or mission. A major challenge for the design of these user interfaces is to not overwhelm the operator with large amount of information coming from the environment and from the robot sensors. At the next stage, artificial intelligence and environmental understanding will be definitely the key drivers of change. Telemetry, internal sensors, and computer vision can recreate a digital replica of the robot and also the environment that can be shared as a virtual digital environment. Remote collaboration, supervision, and training with virtual replicas of the real environment can change the way the operations are planned and prepared. And even the operator can change the point of view where he performs a task and the way he manipulates the remote robot, something that we call the out-of-the-body experience. Computer vision can identify not only object shapes, can also estimate center of gravity and physical properties of the remote object that then we can integrate in our virtual environment. We could perform thousands of online machine learning simulation iterations, gathering data that then can be used as a guidance to the remote operator, enhancing his environmental awareness or evaluating risks in advance. The lines that separate real, remote, and virtual are starting to be a bit blurry. And all this is just with the combination of different technologies that we have available and are used in different fields separately today. And for the far future, of course, we continue planning and dreaming big. The expected improvement on communications, robotics, haptic, and human-machine interface technology will let us operate with high levels of dexterity and integrating different sensing feedback methods. Virtual and physical worlds are blending together, where physical imitation doesn't mean the same. We collaborate at different scales, maybe small avatars interacting with giant robots and even interacting with a real person in Mars. We don't know. We will have time to think about it.
And suddenly, the whole world went into lockdown. And with it, most of the projects looking beyond our borders. With the COVID crisis, we wouldn't even be able to go to the office or access our equipment anymore. So we had to rechannel our engineering efforts to support other businesses in producing medical material and mitigating the impact of the crisis. What was very interesting about this situation was that people quickly started to use a wave of technologies to do things differently to what they used to. People would use Skype to have a coffee with work colleagues rather than meeting in the canteen, for obvious reasons. Bands would even start practicing online, and even here in the UK, pub quizzes started to go online. So we had to shift our focus from how would we provide a near real-time interactive experience with robots on the surface of Mars to redesigning the future of work here on Earth. We had to start rethinking our daily social conventions and how customers behave. We also have to be helping businesses and organizations to mobilize resources at speed and scale, in other words, becoming more agile. And also, we have to be changing the well-established globalized supply chain strategies to some more regional models. If we think about work as we know it, everything is going to change. The way we interact with people, the way we design, build and maintain our products is going to change. Also, the way we sell to our customers and the way we purchase from our suppliers is going to change. The reason for that change is because the way we've been doing it is not efficient anymore. And in many cases, it's not even going to be viable anymore. If we think about it, virtual conferencing tools were in our lives now for many years, and it was only over the last couple of months when people realized about the true value of these technologies. Remote assistance, immersive gatherings like virtual reality conferences and holoportation are just about to become the fundamental tools for running businesses and enabling new business models going forward. And then all these nuances like business travel, commuting time, hours and hours stuck on traffic will transform into efficiency, availability, and agility for the businesses and people who work in them. Therefore, people will be more rested, will be happier, and have a better life and make a better job, not to mention the tremendous benefit that we will be making to our environment. The next point was about how we would help businesses to mobilize resources at speed and scale. The realization for this point came from when the virus struck the hardest. Governments and health organizations asked manufacturing companies for help in producing medical equipment in collaboration with other businesses. This was a real test of agility for those companies. It is all over the news how aerospace, motorsports, automotive, and many other businesses, despite being hit hard by the crisis, they committed to deliver these products onto hospitals. So they designed these products, they adapted the production lines, and they made them, and they shipped them over to where they were mostly needed. However, if this process was a success, it was no doubt because of the dedication of thousands of hours compressed in just a few weeks' worth of labor. All sorts of challenges were faced: CAD data compatibility issues across collaborating partners, lack of skills to put together these new products, not knowing whether the equipment could actually manufacture the components needed, and of course, the unknown situation of whether the components could be shipped to other partners to put together the end product. Wouldn't it be nice, in these circumstances, if each of these production environments were to have their own respective digital twins connected to each other, and with a single entry of the product design, the whole manufacturing process could be validated automatically across the multiple partners? All the equipment would get configured automatically, and the personnel trained on the job. And with all of that, they managed to produce the components right first time. It does sound like a utopia, but all of this has a name, and that name is Smart Factory. And we are already working with businesses adopting some of the pillars that will allow them to get there in the near future. Finally, we need to look into the reconfiguration of the supply chains. As you know, the sourcing of raw materials and subcomponents is one of the key processes of any manufacturing business. During the crisis, global supply chains were disrupted because of the travel bans and lockdowns. The results only highlighted the weaknesses of the current model for factory supply. A lot of manufacturers had to swap from overseas suppliers to local suppliers in order to be able to keep running their business. And here is where the concept of in situ resource utilization that my colleague Jose spoke about kicks really in. Because supply chains around the world we need to transform to reduce or eliminate the need for travel. Also, when these organizations adopt the full potential of smart digital twins, OEMs, Tier 2s, and so on will be able to be connected to their suppliers, and the network will balance automatically the demand, the supply, the quality control, and the know-how to put these products together, therefore automatically building intrinsic resilience. An early example of this model is the factory-in-a-box concept that we developed at the MTC. The whole production is packed in a shipping container that can be deployed worldwide. Components can be produced next door to where the final assembly happens. The factory will know at all times its own capabilities, and entering a new part design will be validated and the whole box configured to produce it as the specifications automatically. The box will also learn to become more and more autonomous the more it gets utilized, and will run iterations of simulations to ensure it always produces at the maximum performance possible.
To finish, as you may have seen during the keynote, Unity has launched Mars. I'm honestly really excited because it's the base stone of the augmented world of the future, helping on the delivery of key and helpful information based on understanding of the environment.
I want to close this presentation with this famous vertigo-inducing image of the Discovery space shuttle from NASA. Our story was just another example of how space-related technology can help to solve challenges here on Earth. The human race is curious and ambitious, and no doubt that we will be traveling across the solar system and beyond. But until then, we must not forget the world that we live in right now and challenge the way we work and live and make things to make sure that not only humans, but all life on Earth will have a future beyond the stars.
Hey guys, thank you so much for the presentation. Wow, you covered some serious ground in that, and I would love to kind of dive in deeper, but we only have time for one question. Um, so I'm just going to kind of ask more of a focused one in terms of. I know you mentioned in the beginning you're talking about some of the haptic technologies that you were, thinking about using for testing with user experience and with the robots. And I'm just wondering if you could talk any more about any of the technologies that you've used and actually found they're effective, and what's the response been with them? Is my audio going through or? All right, we're okay. All right, well, it looks like the audio connection is not working. So I think we're going to probably have to just move on to the next speakers. Um, well, all right, thanks everybody. If you have any questions, feel free just to bring them to the messages. And we're just having a little bit of technical difficulties here, but we're going to go ahead and move on to the next presentation.